The statement came quietly, without fanfare, without press conference or dramatic announcement. Statement is asking, is 3i Atlas not natural? And just a carefully worded another article published through academic channels making a claim so significant that it fundamentally alters how we must think about what's currently passing through our solar system. Avi Loeb, the Harvard astrophysicist who's been analysing 3i Atlas since detection, who's been tracking the anomalies and running the calculations and building the case piece by piece, has finally stated explicitly what the mathematics have been suggesting for weeks. 3i Atlas cannot be a comet. Not, probably isn't. Not, shows unusual features for a comet. Cannot be. The physics doesn't allow it. The observations contradict what natural sublimation processes can achieve. The evidence has crossed the threshold from suggestive to definitive. Before we dive into the mathematics that changes everything, before we examine the proof that makes the artificial hypothesis unavoidable, you need to subscribe to this channel right now, because what follows isn't just another interesting space story, isn't just curiosity about unusual object. This is documentation of the moment when the scientific community acknowledges, whether officially or not, that we're observing technology, that the visitor in our solar system is artificial, that we're not alone and never have been. If you want to follow this investigation as it develops, as more evidence accumulates, as the implications become impossible to ignore, you need to be here. Hit subscribe, enable notifications. This matters too much to miss. This isn't opinion. Isn't speculation based on ambiguous data that could be interpreted multiple ways. This is mathematical proof. Is calculation showing that the observed phenomena exceed what natural processes can produce by factors so large that no amount of special pleading or exotic circumstances can bridge the gap? Is demonstration that if 3i Atlas were a comet, if it were following natural physics, we would be seeing something fundamentally different from what we're actually observing? And since we're not seeing what we should be seeing, since the observations violate the constraints that natural processes impose, the conclusion becomes inescapable. This object is not what we've been told it must be. The anti-tail is what breaks the natural model completely. We've discussed this structure before. The massive stream of material pointing sunward, extending hundreds of thousands of kilometers toward our star rather than being pushed away like normal cometary tails, showing coherence and structure that persists over timescales and distances that strain conventional explanations. But now we have the numbers, have the calculations that quantify exactly why this structure cannot result from natural cometary activity. Have the proof that forces us to confront what we've been avoiding. The structure of 3i Atlas has evolved dramatically since perihelion, since the closest approach to the Sun and the closest approach to Earth. The object isn't static, isn't maintaining constant configuration, instead shows dynamic changes in jet morphology and brightness distribution and geometric relationships that indicate active processes operating according to timescales we can now measure and analyze. And those measurements reveal patterns, symmetries, relationships between features that are too precise to be coincidental. The triple jet structure is the most obvious manifestation. Where initially we observed what appeared to be a single jet, the anti-tail pointing sunward, more detailed analysis using Hubble Space Telescope data processed through rotation gradient filters reveals 3 distinct jets emanating from the nucleus. Not random, not chaotically oriented, but arranged in symmetric configuration that immediately suggests design rather than natural chaos. One jet points roughly toward the Sun. This is the dominant feature. The anti-tail that extends outward to distances exceeding 100,000 kilometers. The structure we've been tracking for weeks. The phenomenon that's been resisting easy explanation through conventional cometary physics. This jet is the most prominent feature on large scales. When you zoom out to view 100,000 kilometers of the structure, the anti-tail dominates. Overwhelms the other features through sheer extent and brightness, But when you zoom into smaller scales, when you examine regions spanning 24,000 kilometers rather than 100,000, the other jets become visible, become distinguishable as separate structures rather than just being lost in the glare of the dominant anti-tail. And their geometry is what forces attention, what creates the pattern that's too organized to dismiss as natural variation. One jet points roughly away from the sun, opposite direction from the anti-tail. This would be the expected orientation for normal cometary activity. Materials sublimating from the sunlit side getting swept back by solar wind and radiation pressure, creating tail that streams behind the object as it moves through space. This is conventional geometry, what every comet we've studied shows, and 3I Atlas does show this feature, but it's weak, much less prominent than the anti-tail, secondary rather than primary. And then there are two additional jets pointing sideways, perpendicular to the Sun-Comet line, oriented at roughly 120 degrees relative to each other and to the primary jets, creating symmetric threefold pattern, Triskelion, arrangement where the angular separations are equal, where 360 degrees divided by 3 gives 120 degrees, and all three jets approximate this spacing with precision that's disturbing when you calculate how unlikely it is to occur naturally. The symmetry is artificial. That's the immediate visual impression. That's what researchers see when they examine the processed images. Three jets equally spaced around the nucleus, maintaining geometric relationship that suggests coordination. That implies the jets aren't independent random features but are instead components of integrated system operating according to design that prioritizes symmetry for reasons we can only speculate about, but that definitely don't align with how natural cometary outgassing works. Natural comets don't produce symmetric jet patterns, don't arrange their active regions in geometric configurations. Instead, show jets emerging from wherever on the surface happens to have volatile ice and happens to be receiving solar heating. The locations are determined by formation history, by what happened during accretion billions of years ago that left ice deposits in certain regions, by how the object has tumbled and rotated and been heated during previous perihelion passages, by chaos, by randomness, by processes that have no reason to create symmetry and every reason to create irregular asymmetric patterns. But 3I Atlas shows symmetry, shows equal angular spacing maintained over time as the object rotates, shows organization that resists easy natural explanation. And when you calculate the probability of 3 randomly placed active regions ending up at 120-degree intervals, when you run the numbers on how unlikely that geometric coincidence is, you get results that make the natural explanation uncomfortable. The probability is roughly 2%. That's the chance that random placement would create this spacing. Small, but not impossible. Not so improbable that you can dismiss natural processes entirely based solely on geometry. Unusual coincidences happen. Low probability events occur occasionally just through random chance. 2% means that if you examine 50 similar objects, you'd expect to see this pattern once, rare but plausible within natural frameworks. Except this isn't the only low probability feature 3I Atlas is showing. Isn't the only geometric coincidence we're being asked to accept. The rotation axis alignment is another. Because for the anti-tail to maintain coherence over the distances we're observing, for it to show collimation that creates jet 10 times longer than it is wide, the rotation axis needs to be aligned nearly perfectly with the direction toward the sun. The jet needs to be located at or very near the rotational pole such that as the object spins, the jet precesses in small cone rather than sweeping through large angles that would disperse the material. The mathematics of collimation are straightforward. If you have jet emanating from surface location that's not aligned with rotation axis, then as the object spins, that jet sweeps around, creates conical pattern. The material ejected spreads across the cone rather than maintaining narrow beam. For anti-tail to be 10 times longer than wide, as observations show, the misalignment between jet direction and rotation axis must be less than 6 degrees, must be nearly perfect, pointing along the pole, and the pole must be pointing nearly toward the sun, must be aligned such that the jet aimed sunward stays aimed sunward as the object rotates. Otherwise you get wobble, get variation, get dispersion that destroys the coherent structure we're observing. The probability of this alignment occurring randomly, of the rotation pole happening to point toward the sun with precision necessary to maintain the observed collimation, is also roughly 2%. So now we're stacking probabilities. 3 jet symmetry at 2%, rotation axis alignment at 2%. Multiply them together and you get 0.04%, 4 chances in 10,000. That's the probability that both geometric coincidences occur simultaneously through random natural processes. Still possible, still within the realm of what random chance can produce, but uncomfortable, increasingly difficult to maintain that natural explanation is adequate when you're requiring multiple low-probability features all aligned in ways that happen to create observed structure. And this is before we get to the mathematics that actually breaks the natural model. Before we examine the calculations that show the anti-tail cannot be created through sublimation, regardless of geometric alignments or jet symmetries or any other features that might make the configuration unusual but still potentially natural. The geometry is suggestive, the symmetry is provocative, but the physics is definitive. The anti-tail extends outward from the nucleus to distances that have been measured repeatedly through multiple observation campaigns. 100,000 kilometers is conservative estimate based on what's clearly visible in standard imaging. The actual extent appears to be larger, multiple hundreds of thousands of kilometers, potentially approaching or exceeding 1 million kilometers when you trace the faintest detectable structures. This is enormous. Is planetary scale feature emanating from object that's roughly 1 kilometer in diameter, is structure that dwarfs the nucleus by factors of 100,000 or more, and it's pointing sunward, is extending toward rather than away from the solar radiation and solar wind that normally push cometary material outward. This geometry has been established beyond doubt, has been confirmed through observations from multiple telescopes showing that yes, the material is moving toward the sun, or at least is positioned between the nucleus and the sun in configuration that defies conventional expectations. The question has never been whether the anti-tail exists. The question is what creates it and sustains it over these enormous distances. The initial explanation invoked large dust particles, grains tens of micrometers in diameter that are heavy enough to resist radiation pressure. That can be launched sunward by gas jets created through sublimation and that continue moving in that direction because they're too massive for sunlight to push back effectively. This explanation worked mathematically. The calculations showed that yes, 10 micrometer particles could be accelerated to hundreds of meters per second by gas flow near the nucleus and could coast outward to distances of hundreds of thousands of kilometers before radiation pressure decelerated them enough to halt their sunward progress. So the dust component was explicable, was consistent with known physics operating on particles in the size range that observations suggested were present. Large grains can create anti-tails. We've seen similar structures on some solar system comets where viewing geometry and particle sizes combine to produce sunward-pointing features. 3I Atlas's anti-tail was more prominent, more extensive than typical examples, but it wasn't fundamentally impossible through natural processes if you accepted that the particle sizes were unusual and that the gas flow was strong enough to accelerate them to the necessary velocities. But there's critical question that this explanation didn't address. What happens to the gas? Because if you're invoking gas jets to accelerate dust particles, If you're claiming that sublimation is creating outflow that drags particles along and launches them sunward, then the gas itself should be present, should be accompanying the dust, should be visible through spectroscopy that can detect gas molecules and measure their densities and velocities and spatial distributions. Gas doesn't just disappear, doesn't conveniently vanish after serving its purpose of launching dust. It continues flowing, continues moving according to the same forces that affected it near the nucleus, and those forces should prevent it from extending as far as the dust can reach. This is where Loeb's calculation becomes devastating, where the mathematics stops being interesting but ultimately reconcilable anomaly and becomes proof that natural processes cannot account for observations. Because while dust particles can potentially reach 100,000 kilometers through ballistic trajectories after initial gas acceleration, the gas itself cannot. Is stopped much closer to the nucleus through interaction with solar wind that pushes back against the outflow with forces that overwhelm the initial ejection velocity. The solar wind is a stream of charged particles, mostly protons and electrons, flowing outward from the Sun at velocities around 500 kilometers per second. At Earth's distance from the Sun, at the region where 3I Atlas has been operating, the solar wind creates ram pressure, creates force opposing any gas trying to flow sunward, acts like headwind that material moving toward the Sun must fight against, and for gas ejected through cometary sublimation, for material launched at the thermal velocities that sublimation produces, that headwind is insurmountable beyond very short distances. The calculation requires determining where the ram pressure of the outflowing gas equals the ram pressure of the solar wind, where the force pushing sunward from gas ejection balances the force pushing anti-sunward from solar wind impact. That balance point is where the gas flow stalls, where further sunward progress becomes impossible because the opposing pressure is too strong, and calculating that balance point requires knowing the gas density, the gas velocity, and the solar wind density and velocity. The gas velocity is constrained by sublimation physics. When ice sublimates, when solid converts directly to gas without passing through liquid phase, the molecules escape at thermal velocities. Speeds determined by temperature and molecular mass according to well-understood thermodynamic relationships. For carbon dioxide, which spectroscopy shows is the dominant volatile in 3I Atlas's coma, the thermal velocity at the temperatures achieved through solar heating at the object's distance from the Sun is roughly 200 meters per second. This is the maximum speed at which gas can be ejected naturally through sublimation. You can't exceed thermal velocity without additional acceleration mechanisms, without something adding energy beyond what solar heating provides. So 200 meters per second is the upper limit for how fast CO2 gas can be moving as it leaves the surface. It might be slower if the sublimation is inefficient or if collisions slow the flow, but it cannot be significantly faster without invoking non-thermal processes. The solar wind velocity is 500 kilometers per second, 500,000 meters per second, 2,500 times faster than the gas ejection velocity. The ram pressure, the force per unit area that a flowing fluid exerts on obstacles in its path, scales as density times velocity squared. So even though solar wind density is much lower than the gas density near the nucleus, the enormous velocity difference means that solar wind ram pressure quickly dominates as you move away from the source of the gas emission. The mass loss rate provides the final constraint, because the amount of gas being ejected determines how far it can flow before the density drops low enough that ram pressure becomes negligible. James Webb Space Telescope observations before perihelion measured the total mass loss rate at roughly 150 kilograms per second. This likely increased during perihelion when solar heating peaked. Loeb estimates that at perihelion the rate might have reached 500 kilograms per second. That's substantial. Is large mass loss compared to typical comets, but it's still finite. Is still limited quantity of gas being distributed across expanding volume as the flow moves away from the nucleus. The gas density decreases with distance following inverse square law. doubles the distance, and the density drops by a factor of 4. The volume the gas occupies increases as the cube of distance, but the gas is flowing outward, so the density decreases as the square of distance rather than the cube. This is standard fluid dynamics, is how any expanding flow behaves, and it means that even vigorous gas ejection becomes dilute rapidly as distance from the source increases. Now you plug in the numbers: 500 kilograms per second mass loss, 200 meters per second ejection velocity, inverse square density decline, solar wind ram pressure at 500 kilometers per second. Calculate where the two ram pressures equal each other, where the outflowing gas meets the opposing solar wind and stalls. The answer is 5,000 kilometers. That's the maximum distance from the nucleus where CO2 gas ejected at thermal velocities can flow sunward before being stopped by solar wind. 5,000 kilometers is the limit. Beyond that distance, the ram pressure from solar wind exceeds the ram pressure from the gas outflow. The gas gets pushed back, gets swept into the conventional tail-streaming anti-sunward, cannot continue toward the sun because the physics doesn't allow it. 5,000 kilometers is tiny compared to the extent of the anti-tail, is 2% of 100,000 kilometers, is half of 1% of the potential million-kilometer extent. The anti-tail extends 20 to 200 times farther than gas can flow if natural sublimation is creating the outflow. The structure we're observing cannot exist if the gas is being launched through thermal processes. The mathematics forbids it. The physics prevents it. The calculation is definitive. And interestingly, 5,000 kilometers is roughly the radius of the coma, the glowing halo around the nucleus visible in Hubble images, the region where gas density is high enough to scatter substantial sunlight and create visible glow. That correspondence isn't coincidence. That's the calculation working. That's the point where gas outflow stalls matching the observed extent of the dense coma. The physics is correct. The numbers match observations, and both confirm that gas cannot extend beyond this limit if sublimation is the source. So if the anti-tail reaches 100,000 kilometers or farther, and if there's gas present at those distances, then sublimation cannot be the mechanism creating the structure. Natural cometary processes cannot account for what we're observing. The object cannot be comet in the conventional sense where solar heating drives volatiles off the surface and creates the characteristic tails we associate with these bodies. And here's where the proof becomes irrefutable. Here's where calculation transitions from theoretical constraint to observational confirmation. Because we don't have to speculate about whether gas is present beyond 5,000 kilometers. We don't have to wonder whether the anti-tail might be composed purely of dust with no accompanying gas at the large distances where gas shouldn't exist. We have spectroscopy. We have direct measurements. We have data from James Webb Space Telescope showing exactly what's present throughout the anti-tail structure. The spectroscopic analysis targeted carbon dioxide specifically, looked for the molecular signature that CO2 creates in infrared wavelengths, measured the strength of that signature as function of distance from the nucleus, created spatial map showing where CO2 is present and at what densities, and the results are unambiguous. CO2 is detected throughout the anti-tail, is present at distances well beyond 5,000 kilometers, is visible in the data at tens of thousands of kilometers from the nucleus, is detectable at 100,000 kilometers, is showing up exactly where natural sublimation says it cannot be. This is the proof. This is the observation that cannot be reconciled with natural processes. You can see the CO2 extending far beyond the limit that ram pressure calculations establish, can measure its presence in regions where physics says it shouldn't exist if thermal velocities are all that's driving the flow, can document that the gas distribution violates the constraints that natural sublimation imposes, and violations of physical constraints mean the underlying assumptions are wrong, mean the mechanism isn't what we thought it was, mean the object isn't what we've been told it must be. 3I Atlas is not a comet. Cannot be a comet. The defining characteristic of comets, the feature that makes them comets rather than asteroids or other small bodies, is sublimation. Is solar heating converting ice to gas and creating outgassing that produces the visible coma and tails? Remove that mechanism and you don't have a comet anymore. You have something else. Something that might look superficially similar, but that operates according to different physics. That requires different explanations, that forces consideration of alternatives that were previously dismissed as unnecessary. The technological hypothesis becomes unavoidable at this point. Not because we want it to be true, not because it's more exciting or more interesting than natural explanation, but because it's the only remaining framework that can account for observations. Natural processes have been ruled out mathematically. The numbers don't work. The physics prevents what we're seeing from being created through sublimation. So either there are unknown natural mechanisms that somehow accelerate gas to velocities far exceeding thermal speeds, or the gas is being ejected through technological means, through propulsion systems that can achieve the velocities necessary to overcome solar wind ram pressure and sustain gas flow to 100,000 kilometers or beyond. And we know what kinds of systems can do this because we've built them. Have developed propulsion technologies that accelerate gas or plasma to velocities ranging from kilometers per second to tens of kilometers per second depending on the design. Chemical rockets, ion thrusters, Hall effect thrusters, electromagnetic propulsion systems that use electric and magnetic fields to accelerate ionized gas to velocities far exceeding what thermal processes can achieve. These are established technologies. Are used on spacecraft we've launched, are understood physics that's been demonstrated repeatedly. Chemical propellant thrusters operate at exhaust velocities around 5 kilometers per second. That's roughly 25 times faster than thermal sublimation produces. And according to the same ram pressure calculation that established the 5,000 kilometer limit for natural gas, a propulsion system ejecting gas at 5 kilometers per second could sustain flow out to 25,000 kilometers before solar wind pressure becomes dominant. That's 5 times farther than sublimation allows. Still not sufficient to reach 100,000 kilometers, but dramatically better than natural processes. Ion thrusters are even more capable. These systems ionize gas, typically xenon, but increasingly other propellants, including carbon dioxide, are being explored, and then accelerate the ions through electromagnetic fields. The acceleration can be enormous because electromagnetic forces acting on charged particles are far stronger than thermal pressure can create. Modern ion thrusters achieve exhaust velocities around 90 kilometers per second. Some experimental designs exceed this, and at 90 kilometers per second, the ram pressure calculation shows that gas flow could extend to 100,000 kilometers before being stopped by solar wind. That matches observations. That accounts for the spatial extent of CO2 detected in the spectroscopic data. That provides mechanism capable of creating what we're actually seeing rather than what we wish we were seeing to keep the natural explanation viable. Ion propulsion at exhaust velocities characteristic of our current technology can sustain gas flow to exactly the distances where JWST is detecting carbon dioxide in 3I Atlas's anti-tail, and carbon dioxide happens to be propellant that's being investigated for ion thruster applications, is being studied as alternative or supplement to xenon in multi-propellant systems where mixing different gases provides operational advantages. Xenon has high atomic mass which makes it efficient for momentum transfer, is easy to ionize which simplifies the thruster design, but it's expensive, is rare element that costs thousands of dollars per kilogram. Using pure xenon for large-scale propulsion becomes economically prohibitive. Carbon dioxide is abundant, is cheap, can be extracted from atmospheric sources on planets that have CO2-rich atmospheres like Mars or Venus, can be manufactured from carbon and oxygen, which are common throughout the solar system, and recent research has demonstrated that CO2 can be ionized and accelerated effectively in ion thruster configurations. The exhaust velocity is slightly lower than pure xenon would achieve because CO2 molecules are lighter, but the trade-off is acceptable if you're optimizing for propellant availability rather than maximum specific impulse. If 3I Atlas is using ion propulsion, if the anti-tail is exhaust plume from thrusters operating to provide thrust or to create other effects, then detecting CO2 in the exhaust makes perfect sense, becomes expected signature rather than anomaly, becomes evidence supporting technological origin rather than mysterious feature requiring convoluted natural explanations. The spectroscopy that was supposed to characterize the composition of naturally sublimating ice instead reveals the propellant choice of the probe's designers. But there's alternative interpretation for why you'd want to eject ionized CO2 toward the sun, why you'd create persistent stream of charged particles flowing sunward to distances of 100,000 kilometers or more, and this interpretation relates to protection rather than propulsion, to defense rather than thrust, to using the plasma not to move the spacecraft but to shield it from radiation environment that would otherwise be damaging or dangerous. The solar wind is radiation hazard, is continuous stream of high-energy particles that can damage electronics, degrade materials, and pose risk to anything that isn't adequately shielded. For natural objects, this isn't concern. Rock and ice don't care about radiation, don't have sensitive systems that can be disrupted or destroyed, can absorb enormous radiation doses without functional consequence. But for technology, for spacecraft with computers and sensors and communication systems, radiation is enemy, requires shielding or countermeasures or both to enable survival in hostile radiation environment. Traditional shielding is passive, is mass. Layers of material that absorb or scatter incoming particles before they can reach sensitive components. Works well but is heavy. Requires carrying substantial mass that serves no purpose except protection. For spacecraft where every kilogram costs fuel and limits capability, passive shielding is expensive, is trade-off between protection and performance. And for missions crossing interstellar distances where minimizing mass is critical to achieving necessary velocities, heavy shielding becomes increasingly problematic. Active shielding offers alternative approach. Instead of blocking particles with mass, you deflect them with fields. Electromagnetic fields can interact with charged particles, can exert forces that bend trajectories, can create regions where particle flux is reduced, not because particles are absorbed, but because they're redirected around the protected volume. This concept has been studied extensively for human spaceflight, where reducing radiation exposure during long-duration missions is a critical challenge. And while implementation faces significant engineering obstacles, the physics is sound. Magnetic fields can deflect charged particles. Plasma shields can absorb their energy. Active protection is possible if you can generate the necessary fields and sustain them against the continuous particle bombardment. The anti-tail could be plasma shield, could be stream of ionized gas, primarily CO2, that's being ejected sunward to intercept incoming solar wind before it reaches the nucleus. The ions in the exhaust plume would interact with the charged particles in solar wind through electromagnetic forces, would scatter them, would absorb their kinetic energy, would create buffer zone where solar wind flux is reduced because particles are being removed from the stream before they impact the spacecraft itself. The physics of this interaction is well understood, is the same physics that limits how far sublimated gas can flow against solar wind ram pressure, but reversed. Instead of trying to push through the solar wind, you're using the interaction deliberately, are positioning plasma between your spacecraft and the radiation source, are allowing the solar wind to impact the plasma shield rather than the spacecraft, are sacrificing propellant to protect hardware. And the scale of the anti-tail makes sense in this context. A shield needs to be large enough to intercept all the particles that would otherwise hit the protected object, needs to extend far enough sunward that particles are deflected or absorbed before they can reach the spacecraft. 100,000 kilometers or more provides substantial buffer, ensures that even particles with high enough energy to penetrate closer to the nucleus get slowed and scattered by interactions in the extended plasma region, creates layered defense where multiple collisions degrade particle energy progressively until the flux reaching the nucleus is reduced to manageable levels. This would explain why the anti-tail intensified after perihelion, why it became more prominent as 3I Atlas moved away from closest approach to the Sun. Because during perihelion passage the radiation environment was most intense, solar wind density and particle energies were highest. The need for protection was greatest. Operating a plasma shield during that period makes strategic sense, provides maximum protection when threat is highest, and maintaining the shield post-perihelion as the object continues through the inner solar system ensures continued protection against radiation environment that remains significant even at increasing solar distances. The energy requirements for this are substantial but not impossible. Ionizing hundreds of kilograms per second of CO2 and accelerating it to tens of kilometers per second requires power on the order of megawatts. That's far beyond what solar panels could provide at the distances where 3I Atlas is operating. But if the object has nuclear power source, if it carries reactor or radioisotope system capable of sustained high power output, then megawatt-level operations become feasible, become the kind of capability that advanced civilization designing interstellar probe would build into the architecture because power enables everything. Enables propulsion and sensing and communication and defense and all the other functions that long-duration autonomous mission requires. The blue glow that's been observed strengthens this interpretation, because ionization and acceleration of gas creates visible emission, produces light as atoms and molecules transition between energy states. And the color of that emission depends on what's being ionized and how energetic the process is. Blue light is characteristic of high-energy processes, is what you see from hot plasmas and from electrical discharges and from ion thrusters in operation. If 3I Atlas is running plasma shield or ion propulsion system using CO2 propellant, the blue glow is exactly what you'd expect to observe as waste light from the ionization and acceleration processes. And the glow intensifies as the object moves away from the Sun, which contradicts thermal emission expectations, but makes perfect sense if the emission is from active systems ramping up their power output, if the shield is being strengthened post-perihelion, if propulsion is being used more aggressively to adjust trajectory, if whatever mission the probe is executing requires higher power consumption as it moves into the phase following closest approach. The blue glow isn't passive thermal radiation, is active emission from systems in operation, and its behavior tracks operational status rather than solar heating. But there's third possibility that's even more speculative, but that would explain both the anti-tail structure and some of the other anomalies if it's correct. The possibility that the dust in the anti-tail isn't dust at all, isn't 10 micrometer grains of solid material being dragged along by gas flow or plasma, is instead something active, something that operates, something designed to do specific jobs and that gets deployed into the solar wind to execute those functions. Nanomachines is the term that gets used, though the scale is more accurately micromachines given that we're talking about 10 micrometer particles. Still far smaller than anything humans have built that could operate autonomously, but not impossible. Not beyond what technological civilization more advanced than ours might achieve. And if you could build autonomous systems at that scale, if you could create particles that could harvest energy and process information and execute programmed behaviors, then deploying millions or billions of them into the solar wind creates capabilities that passive shielding or simple propulsion can't provide. Energy harvesting would be obvious application. The solar wind carries enormous energy flux, kinetic energy of the particles streaming past. If you could capture that energy, if you could convert particle impacts into electricity or heat or stored chemical energy, then you've built a power collection system that operates in regions far from the Sun where solar panels would be ineffective. Each micromachine could act as tiny collector, could absorb incident particles, could convert their kinetic energy through whatever mechanism the device uses, and could either store that energy locally or transmit it back to the parent spacecraft through mechanisms we can only guess at. Microwave transmission is one possibility if the micro-machines can generate microwave radiation, and if the nucleus has receivers tuned to detect those frequencies, then energy could be beamed back wirelessly. The efficiency would be low, losses would be significant. But if you're deploying billions of collectors, and if each contributes small amount, then the aggregate becomes substantial, becomes meaningful power input that supplements whatever onboard generation the spacecraft has, becomes renewable resource harvested from the environment rather than depleting finite reserves carried from the origin system. Or the particles could return physically, could collect energy, store it in some form, and then allow the solar wind to push them back toward the nucleus where they're collected and the stored energy is extracted. The deployment would be continuous, new particles launched sunward to replace ones that have been blown back, creating cycle where the anti-tail is constantly refreshed with new collectors while old ones return and deliver their harvest. The structure would appear static from our observations, but would actually be dynamic, would be flowing continuously with material moving both directions along the stream. This would explain why the anti-tail persists, despite solar wind pressure. Because you're not fighting the pressure, you're using it. You're deliberately allowing particles to be pushed back after they've completed their collection phase. The outflow you need to maintain is just the fresh deployment to replace returned collectors. And that requires much less power than sustaining persistent stream all the way to 100,000 kilometers against continuous opposition. You need enough thrust to launch particles to where the solar wind catches them. After that, the wind does the work of transporting them back to you. The spectroscopic detection of CO2 throughout the anti-tail would still be explained through this mechanism if the propellant used to launch the collectors is CO2 and if some of that gas remains mixed with the particle stream as it extends outward. Or if the micro-machines themselves use CO2 as working fluid or as byproduct of whatever energy conversion they're performing. We're speculating now, building scenarios on top of scenarios. But the underlying point is that if you allow for technological sophistication beyond our current capabilities, if you assume the probe was built by civilization that can do things we can't yet do, then interpretations become possible that seem far-fetched from human technology perspective, but that might be routine for others. Regardless of which specific mechanism is operating, whether it's propulsion or shielding or energy harvesting or something we haven't thought of, the fundamental conclusion remains unchanged. The anti-tail cannot be explained through natural sublimation. The mathematics proves this definitively. The spectroscopic observations confirm gas is present where it cannot be if thermal processes are responsible. Therefore, the anti-tail is technological, is created by systems that operate according to engineering principles rather than passive response to solar heating. And if the anti-tail is technological, if that structure requires artificial systems to create and sustain it, then 3I Atlas as a whole cannot be natural comet, because the anti-tail isn't separable add-on, isn't independent feature that happens to be associated with otherwise natural object, is integral part of what the object is doing, is primary observable characteristic that dominates the visual appearance and the spectroscopic signature and the behavior patterns. You can't have technological anti-tail attached to natural comet nucleus. The scale is wrong. The energy budget is wrong. The integration doesn't work. If the anti-tail is artificial, then the object producing it must be artificial, must be designed system carrying the propulsion or defense or harvesting capability that creates the structure we're observing, must be probe, must be spacecraft, must be technology rather than geology. And that conclusion, that definitive statement that this object is not a comet, is what Loeb's analysis establishes, is what the mathematics forces us to accept once we examine it honestly without prejudice about what we want the answer to be. The mainstream scientific community needs to acknowledge this, needs to stop defaulting to natural explanations when the natural explanations have been proven inadequate, needs to accept that we're observing technology, even though that acceptance carries implications that are uncomfortable and that raise questions we don't have answers to. Because denying what the data shows, because the implications are disturbing, doesn't serve science, doesn't serve truth, doesn't serve humanity's need to understand what's actually happening in our cosmic neighborhood. The evidence is clear. The calculations are public. The observations are documented in peer-reviewed literature and in archived telescope data that anyone can access and analyze. There's no secret here. No hidden information that only privileged few have access to. The proof that 3I Atlas cannot be natural comet is available for examination by anyone with sufficient background in physics and fluid dynamics to follow the arguments. And those who have examined it are reaching the same conclusion. The natural model is broken, the observations violate the constraints, the object must be artificial. But acknowledgement at institutional level remains hesitant, remains cautious to the point of being evasive. Official statements continue treating 3I Atlas as unusual comet rather than as technological artifact, continue suggesting that better understanding of exotic cometary processes will eventually explain the anomalies rather than accepting that the anomalies are evidence of design, continue maintaining comfortable fiction that we're studying natural visitor rather than confronting reality that we're being visited by intelligence from beyond our solar system. This conservatism is understandable to some degree. Making official statement that interstellar visitor is artificial carries enormous weight, creates headlines, triggers policy questions, forces governments and institutions to respond to scenario they haven't prepared for. Easier to maintain ambiguity, to allow multiple interpretations to coexist, to avoid making definitive claims until the evidence is so overwhelming that no alternative remains viable. That cautious approach is professionally safe, protects individuals and institutions from being wrong about something so significant. But it's also intellectually dishonest when the evidence has already crossed the threshold, when the mathematics has already proven that natural explanations are impossible, when continuing to treat artificial origin as one speculative option among many rather than as the conclusion that observation's force requires ignoring or dismissing the quantitative analysis that establishes the impossibility of the alternative. That's not caution, that's denial, and it serves no purpose except delaying the necessary reckoning with what we're actually observing. The calculations are clear. 5,000 kilometers is the maximum distance natural sublimation can sustain CO2 flow against solar wind pressure. 100,000 kilometers is the minimum extent of the anti-tail where spectroscopy detects CO2. The gap between those numbers is factor of 20. Is difference that cannot be bridged through better modeling or refined parameters or consideration of exotic circumstances. Is violation of physical law if you maintain that thermal processes are responsible. And violations of physical law mean your assumptions are wrong, mean the framework needs to change, mean artificial origin isn't speculation anymore, but is instead the only viable explanation remaining. The triple jet symmetry reinforces this conclusion even though it doesn't prove it independently, because 120-degree spacing is what you'd expect from engineered system optimizing geometric efficiency, is natural choice for three-way symmetric configuration, is what designers would select if they were arranging three jets around nucleus and wanted equal angular separation. The 2% probability that this occurs randomly is low enough to be suggestive. Combined with the 2% probability of rotation axis alignment and multiplied by the 0% probability that sublimation creates the anti-tail, you get cumulative case that's overwhelming. 0% needs emphasis because it's not rhetorical exaggeration. The anti-tail observation combined with the ram pressure calculation doesn't just make natural explanation unlikely or improbable, makes it impossible. You cannot have CO2 gas at 100,000 kilometers from the nucleus if thermal sublimation is the ejection mechanism. The physics absolutely forbids it. So the probability that natural processes explain what we're seeing isn't small, is actually zero. And once probability reaches zero for one hypothesis, the alternative hypothesis becomes certain regardless of how improbable it might have seemed initially. This is Bayesian reasoning operating correctly. You start with priors about how likely each hypothesis is. Natural comet might have prior probability of 99%. Artificial probe might have prior of 1%, reflecting our uncertainty about how common technological civilizations are and whether they send probes to other stellar systems. But then you update based on evidence. Each observation that favors one hypothesis over the other shifts the probabilities. And when you encounter observation that's impossible under one hypothesis but expected under the other, that observation drives the probability of the impossible hypothesis to zero and the alternative to 100%. The CO2 detection beyond 5,000 kilometers is that kind of observation, is data point that's impossible if natural sublimation is operating but is expected if technological propulsion or shielding or harvesting is responsible. So it doesn't matter that you started with 99% confidence in natural origin. The evidence forces complete reversal, drives natural probability to zero, establishes artificial origin with certainty based purely on what the observations require rather than on what our preferences or prejudices suggest. And this is how science should work. How evidence-based reasoning should operate when encountering phenomena that challenge existing frameworks. You don't cling to comfortable explanations when the data contradicts them. You don't maintain agnosticism when the mathematics establishes definitive conclusions. You accept what the observations show even when acceptance requires revising fundamental assumptions about what you're studying. That's intellectual honesty. That's following evidence wherever it leads. That's what distinguishes science from dogma. The technological interpretation opens questions we can't fully answer without more data. Questions about purpose and origin and capabilities and intentions. Why is 3I Atlas here? Where did it come from? Who built it? What is it trying to accomplish? These are profound questions, are exactly the kind of inquiry that makes the artificial hypothesis uncomfortable because the answers lie beyond our current observational capacity and might remain beyond our reach indefinitely. But unanswerable questions don't invalidate the conclusion that the object is artificial, don't justify retreating to natural explanations that have been proven wrong. We can acknowledge that we're observing technology while simultaneously admitting we don't understand that technology or know its purposes, can accept that the probe is artificial without being able to decode its mission or communicate with its builders, can recognize intelligence in the design without being able to characterize that intelligence or predict how it will behave. This is humility, is accepting the limits of what we can determine from available observations while insisting on honesty about what those observations do show. 3I Atlas is not a comet. That's established, is proven through mathematics that's reproducible and through spectroscopy that's documented. What it is instead, what capabilities it has, what goals it serves, those remain uncertain, require investigation, require more data that we might or might not be able to collect before the object leaves the solar system and becomes too distant to study effectively. But the investigation should proceed from accurate foundation, should start from acknowledgement that we're studying artificial object rather than natural one, should direct resources and attention toward questions that are actually relevant rather than continuing to debate whether natural mechanisms can explain phenomena that we've already proven they cannot explain. That's efficient use of limited observation time and analytical resources. That's how you make progress when studying something genuinely new rather than spinning in circles trying to force anomalous observations into inadequate frameworks. The time remaining is finite. 3I Atlas will eventually exit the inner solar system, will recede to distances where detailed spectroscopy becomes impossible, where tracking becomes difficult, where the opportunity to gather additional data diminishes and eventually ends. We have weeks or months, possibly a year or two if we're fortunate, before the object becomes too faint and too distant to characterize further. That window needs to be used effectively, needs to focus on questions that might actually be answerable rather than on defending positions that the evidence has already contradicted. The implications cascade outward from the central conclusion like ripples from stone dropped into still water. Each consequence creates new questions. Each realization forces reconsideration of assumptions we've held for as long as we've been looking at the sky and wondering whether we're alone. Because if 3-eye atlas is artificial, if we've definitively established that this object is technology rather than geology, then we're not alone. That's the immediate and inescapable conclusion. Intelligence exists beyond Earth, has existed long enough to develop interstellar travel capability, has built hardware sophisticated enough to cross the vast distances between stars and to operate autonomously for whatever duration the journey required. And that intelligence has visited our solar system. Not in the ancient past that we can conveniently relegate to mythology or dismiss as unprovable. Not in the distant future that we can defer thinking about until we're more prepared, but now, in our lifetimes, during a period when we have instruments capable of detecting the visitor and characterizing its properties and recognizing the signatures that distinguish technology from nature. The timing is almost suspicious. Almost suggests correlation between our development of observational capabilities and the appearance of objects we're finally able to recognize as anomalous. But that correlation might be selection effect rather than causation. Might be that interstellar probes pass through stellar systems continuously but are only detected by civilizations that have reached sufficient technological sophistication to notice them. That we're joining a community that's always been here, but that remained invisible to us until we developed eyes sharp enough to see. That the galaxy has been populated with intelligence and infrastructure for far longer than we've existed, but we're only now crossing the threshold where we can recognize that population. If that's true, if probes are common and we're simply late to noticing them, then 3-eye atlas is probably not unique. Is probably one of many visitors currently in our solar system or passing through on trajectories we haven't detected yet. The trillion object calculation from earlier analysis takes on different meaning in this context. Maybe that enormous population isn't all natural debris. Maybe substantial fraction is artificial. Is network of probes and relays and sensors deployed by civilizations that explored this region of the galaxy long before humans existed and that maintain presence through hardware that continues operating long after its builders might have disappeared. The geological timescales involved are humbling. Interstellar travel, even at relativistic velocities, takes years to decades to reach nearby stars, takes centuries to millennia to cross significant portions of the galaxy. Missions operating on these timescales require longevity, require systems that can function for periods exceeding human lifespans by orders of magnitude, require autonomy because real-time control across light years is impossible, and even receiving updated instructions takes years. Building hardware that operates reliably for millennia is an engineering challenge we've barely begun to address. Our longest operating spacecraft, Voyagers, launched in 1977, are approaching 5 decades of operation and are failing. Systems are shutting down as power dwindles and as components degrade from age and radiation exposure. We measure mission lifetimes in years or decades at most. The idea of probe that could operate for thousands or millions of years while crossing interstellar space and executing complex mission in target stellar system is beyond our current capabilities by vast margin. But it's not impossible, isn't forbidden by physics, is just engineering problem requiring solutions we haven't developed yet, but that more advanced civilizations certainly could. Redundancy, self-repair, radiation hardening far exceeding what our technology achieves. Power systems that don't degrade significantly over millennia. Materials that don't deteriorate. Designs that account for component failures and that route around damage automatically. All achievable in principle if you have sufficient technological sophistication and if you're willing to invest the resources required. And if you're civilization that thinks on timescales where thousand-year missions are routine, if your institutional continuity extends across periods that would encompass rise and fall of entire human civilizations, then building probes for extreme longevity becomes standard practice rather than extraordinary challenge. You design for the mission duration you need. You build to the reliability standards the mission requires. You invest in quality because failures mean loss of irreplaceable data from destinations you might not visit again for millennia. 3i Atlas might be older than human civilization, might have been traveling through space for longer than we've had writing, or agriculture, or cities, might have visited hundreds or thousands of other stellar systems before reaching ours, might carry observations of our solar system from previous passes if it's on cyclic trajectory that returns periodically, might have data about Earth from epochs before humans existed, from the age of dinosaurs or earlier, recording evolution of our biosphere across geological time through patient observation conducted by machines that don't experience time the way biological organisms do. These possibilities are speculation, but they're grounded in the reality that the object is artificial, and that artificial objects created by advanced civilizations would have capabilities and purposes we can only partially imagine. We're looking at this from the perspective of species that's been technological for maybe 2 centuries if you're generous about when to start counting. Species that's been spacefaring for barely 7 decades. Species that sent exactly 5 objects on trajectories that will eventually leave the solar system, and all of those will be defunct within decades from now. Comparing our capabilities to what civilization 1,000 or 1,000,000 or 1,000,000,000 years more advanced might achieve is exercise in humility. We can't really comprehend what's possible at those timescales, can't predict what technologies might be developed or what priorities might guide their application, can't assume that our current understanding of what's difficult or impossible reflects actual limits rather than just limits of our current knowledge and capability. So when we observe 3i Atlas exhibiting capabilities that exceed our technology, when we see propulsion or shielding or energy harvesting that we can barely conceive of implementing, we shouldn't be surprised. Should expect that probe built by civilization far older than ours would do things we can't do and would operate according to principles we haven't mastered. The surprise would be if it looked like something we could build, if its capabilities matched our own. That would actually be suspicious, would suggest either remarkable coincidence in technological development or something stranger like the probe being designed to appear roughly equivalent to whatever civilization encounters it. The purpose question is what everyone wants answered. Why is 3i Atlas here? What is it trying to accomplish? Is it observing us specifically or just surveying the solar system generally? Is Earth the target or just one data point among many being collected about planetary systems across the galaxy? Are we being evaluated for some purpose or just catalogued as part of comprehensive survey that documents everything without attaching special significance to any particular finding? We can't answer these questions with certainty, can build scenarios but can't prove which, if any, is correct without data we don't have and might not be able to acquire, but we can reason from what we observe, can make inferences about what the behavior suggests even if those inferences remain provisional. The anti-tail points toward the sun. If it's shield protecting against solar wind, that's defensive posture, that's protection against environmental hazard. Suggests the probe needs to operate close to the star despite radiation environment and is using active countermeasures to enable that operation. Why operate close to the star? Power collection is obvious answer if you're using solar energy. But the blue glow suggests internal power source rather than dependence on sunlight. So maybe it's not about power, maybe it's about position. Maybe being in the inner solar system serves observational or communication purposes that require accepting radiation exposure and implementing protection. Or the anti-tail is propulsion exhaust, is thrust being applied to adjust trajectory or to maintain position against gravitational perturbations. The direction toward the sun would create force pushing the object outward, would counteract solar gravity, would allow the probe to maintain specific orbital parameters that might be important for mission objectives. This interpretation treats the anti-tail as functional system serving navigational purposes rather than as passive structure resulting from sublimation. The trajectory evolution supports propulsion interpretation. The object has shown acceleration anomalies, has deviated from purely gravitational path in ways that indicate thrust being applied, has altered its course since detection, suggesting active navigation rather than passive ballistic flight. These deviations are consistent with anti-tail being exhaust plume from propulsion system that fires when trajectory adjustments are needed. The triple jet structure might provide attitude control. 3 jets spaced symmetrically around the body could be reaction control system, could fire selectively to create torques that rotate the spacecraft or that counteract unwanted rotation from other forces. The symmetry makes sense in this context, provides balanced thrust options in multiple directions, allows complex maneuvers through coordinated firing of different combinations of jets. If this interpretation is correct, if the jet structure is propulsion and control architecture, then we're observing spacecraft actively navigating, executing maneuvers, following programmed trajectory or responding to environmental conditions by adjusting course, not passively falling through the solar system, but deliberately moving through it according to mission plan that requires specific positions and orientations at specific times. The rotation period of 16 hours might be operational choice rather than natural tumbling, might be scan rate as suggested earlier, might be the time required for instruments to complete full survey of the surroundings, might be communications period where the probe rotates to maintain contact with multiple targets or to sweep beam across regions of space where receivers might be located. The stability of the rotation, the lack of variation over weeks of observation, indicates active control, maintaining desired spin rate against perturbations that would otherwise change it. All of this adds up to picture of operational spacecraft executing mission, not derelict, not abandoned hardware drifting mindlessly through space, but active system doing things, navigating, observing, possibly transmitting, operating according to whatever program it was designed to execute when passing through stellar systems like ours. The question of whether we're the target remains ambiguous. The trajectory brought the object close to Earth, passed within distances where detailed observation of our planet would be possible, but it also approached the Sun, which is an interesting target in its own right. And the current trajectory is carrying it toward the outer solar system, where gas giants and icy bodies offer different observational opportunities. Is this comprehensive survey of the entire system? Or is Earth the primary focus with other observations being secondary objectives accomplished during the same visit? The particle deployment suggests Earth is a significant target because those 10 micrometer grains are entering our atmosphere, are being collected by our instruments, are providing physical samples that we can analyze and that reveal composition and structure. If the particles are sensors, if they're designed to sample atmospheric conditions, then Earth is definitely being studied, is receiving focused attention that goes beyond passive observation from distance. The timing of particle deployment after perihelion, after closest approach to both Sun and Earth, suggests the particles might have been released specifically to interact with our atmosphere, to settle through it, collecting data as they descend, to measure composition and temperature profiles and radiation levels and whatever other parameters sensors that sophisticated could detect. That's targeted investigation. That's treating Earth as subject worthy of detailed study rather than just another planetary body to be catalogued during flyby. But we're anthropocentric, tend to assume we're important, that anything visiting the solar system must be here because of us, that Earth and life, and especially intelligent life, are so interesting that they must be the primary reason for the mission. That bias could be misleading us, could be causing us to interpret observations as Earth-focused when they're actually more general, when we're one target among several that all received similar attention during the probe's passage. Mars would be interesting target. Has history of water. shows evidence of past potentially habitable conditions, would be worth investigating if you're surveying for life or past life or conditions that support biology. Venus would be interesting despite hostile surface conditions, thick atmosphere, complex chemistry, extreme environment that reveals how terrestrial planets can evolve. Gas giants would be interesting for their magnetospheres and ring systems and moon populations. Outer system would be interesting for volatile compositions and primordial materials preserved in cold storage since solar system formation. Comprehensive survey of all these targets makes sense as mission architecture for interstellar probe, maximizes science return from the long journey, provides data about full range of conditions and processes operating in the target system. Earth might be most interesting target because of biosphere and technology, but might not be only target, might be one element of broader survey that treats the entire solar system as laboratory for studying planetary formation and evolution and the emergence of life and intelligence. We won't know unless we can determine what the probe is observing and what data it's collecting and whether that data is differentiated by target. And we can't determine that without better understanding of how the probe operates, what its sensors are, where they're pointed, what signals it might be transmitting, none of which we can reliably establish from current observations. We see the anti-tail and the jets and the particle deployment, can measure spectra and trajectories and brightness variations, but can't decode what any of it means in terms of mission objectives without access to documentation we don't have. This is frustration of observing technology without understanding it. You can see that it does things, can measure some aspects of its operation, but can't determine purpose or decode function without either communicating with the builders or reverse engineering the hardware. And we can't do either. Can't communicate because we don't know if the probe is listening or how to format messages it might understand. Can't reverse engineer because we can't reach the probe to examine it directly, and even if we could, our technological understanding might be insufficient to comprehend what we're looking at. So we're reduced to inference, to building scenarios that might explain observations, to testing those scenarios against new data as it becomes available, to gradually constraining possibilities until hopefully we arrive at understanding that's at least approximately correct, even if details remain uncertain. This is slow process. Is how science progresses when studying systems that can't be controlled or manipulated experimentally. Through patient observation and careful reasoning and willingness to revise conclusions when evidence demands. The mainstream scientific community's hesitation to accept artificial origin is obstacle to this progress, because refusing to acknowledge what the evidence shows, refusing to start from the foundation that the object is technology rather than geology, prevents asking the right questions and directing resources toward observations that might actually be informative. If you're still debating whether it's natural or artificial after mathematics has proven natural is impossible, you're wasting time and attention that could be spent on questions that matter. What is the propulsion system and how does it achieve the exhaust velocities we infer from CO2 distribution? What are the particles and can we collect enough of them to analyze structure beyond just composition? Is there communication occurring and can we detect signals that might reveal operational status or mission parameters? What is the trajectory evolution teaching us about navigational capability and destination, if any? These are productive questions, are inquiries that advance understanding regardless of whether we can answer them completely. Continuing to propose exotic natural mechanisms that might somehow reconcile observations with cometary physics isn't productive, is defensive intellectualism that protects comfortable assumptions at the cost of engaging honestly with data. The natural mechanisms keep getting more exotic as each is proven inadequate. Supervolatiles that we don't detect, internal heat sources that we can't measure, structural configurations that we can't observe. Each explanation requires invoking phenomena we can't verify to avoid accepting conclusion that observations directly support. At some point this becomes absurd, becomes intellectual dishonesty rather than appropriate scientific caution. And we've crossed that point. The mathematics establishing that natural sublimation cannot create the anti-tail is rigorous. The spectroscopic detection of CO2 beyond the natural limit is unambiguous. The conclusion that the object must be artificial is forced by the data rather than being speculative interpretation. Continuing to resist that conclusion doesn't serve science, serves only the desire to avoid confronting implications that are uncomfortable. Those implications are profound, are exactly the kind of discovery that redefines how humanity thinks about its cosmic context. That's intimidating, is why the resistance exists. Because accepting that 3I Atlas is artificial means accepting that we're being visited, that we're being observed, that intelligence from beyond has capabilities we don't possess and purposes we don't understand, and potentially has been operating in our neighborhood for longer than we've existed. Those are heavy realizations, are the kind of knowledge that changes everything about how we think about our future and our significance and our isolation. But reality doesn't care about our comfort, doesn't adjust itself to maintain our preferred narratives. The object is what it is regardless of whether we want it to be artificial. The evidence shows what it shows regardless of whether acknowledging it creates difficult questions. Science requires following evidence even when it leads to uncomfortable places, especially when it leads to uncomfortable places, because those are exactly the situations where bias is most likely to distort our reasoning if we're not vigilant. The community needs to move past denial, needs to accept the conclusion that mathematics and spectroscopy establish, needs to start from the foundation that 3I Atlas is artificial and that therefore we're studying technology created by non-human intelligence. That acceptance doesn't mean we understand the technology or can explain all its capabilities or know its purposes. Means only that we're being honest about what category of phenomenon we're investigating, and that honesty enables better questions and more productive observations than continuing to pretend the natural explanation remains viable. The opportunity to study this object closely is limited, will end when it recedes beyond observational range. Months from now, or at most a couple years, the window closes. What we learn during that window depends on what we look for, what questions we ask, what observations we prioritize, and those choices should be informed by accurate understanding of what we're studying rather than by defensive adherence to frameworks that the evidence has falsified. If we accept that it's artificial, we can focus on characterizing the technology, on understanding propulsion and power and control systems to the extent our observations allow, on analyzing the particles to determine if they're sensors or just inert material, on searching for communication signals that might reveal operational details, on tracking trajectory evolution to see if patterns emerge that suggest destinations or maneuvers serving specific purposes. These investigations might succeed or might fail, but they're aimed at questions that are actually relevant rather than at defending positions that mathematics has already disproven. And if we're very fortunate, if the probe's mission includes communication, or if it responds to our presence in detectable ways, we might learn more than passive observation can reveal, might receive information deliberately transmitted, might detect signatures that were designed to be recognized, might find that the probe wants to be understood, at least to the extent that understanding serves whatever purposes its builders had in mind when designing the mission. But communication requires recognition, requires the observed civilization reaching sufficient sophistication to notice the probe and to characterize it as artificial rather than dismissing it as natural anomaly. Maybe that's the filter. Maybe the probe operates covertly until target civilization demonstrates capability to detect it and recognize what it is. And once that recognition occurs, once the civilization proves it can see and understand, then contact becomes possible. Then communication protocols activate. Then whatever message the probe carries becomes accessible. We might be at that threshold now. might have just crossed it through the analysis that proves artificial origin, might have triggered response protocols that we'll detect in coming weeks or months as the probe adjusts its operations based on recognizing that we've recognized it. This is speculation, but it's grounded in the logic of how you design first contact if you wanted it to be graduated, if you wanted to ensure the contacted civilization had achieved minimum capability before exposing them to full implications of the network they're joining. Or maybe the probe doesn't care whether we recognize it, operates according to fixed programming that executes regardless of what we observe or conclude, continues its mission indifferent to our detection or our understanding or our attempts to communicate, completes its objectives and departs on schedule without ever acknowledging our existence. That's equally plausible interpretation. Assumes the mission is about data collection rather than interaction, about observing rather than engaging, about documenting civilizations that arise without interfering with their development. We can't know which scenario is correct without observing how the probe behaves now that the artificial conclusion has been established publicly, whether anything changes in its operations, whether new signatures appear, whether communications that were absent or unrecognized before become detectable. The next weeks and months will be telling, will either show that recognition triggered response or will show that the probe continues unchanged, indifferent to our awareness. Either outcome teaches us something about how the network operates and what purposes it serves. But regardless of whether communication occurs, regardless of whether we learn the probe's purposes directly, the fundamental conclusion stands. 3I Atlas is not a comet, is artificial object, is technology created by intelligence from beyond our solar system. That's established. That's what the mathematics proves and what the observations confirm. And that conclusion alone, even without understanding details or purposes or origins, is most significant discovery in human history, is definitive answer to the question we've been asking since we first looked up and wondered whether we're alone. We're not alone. The probe proves it, and now we have to figure out what that means and how to respond and what our responsibilities are to this knowledge. Those are the challenges that follow from acceptance. That's the work that begins once denial ends. And the sooner the mainstream scientific community accepts what the evidence shows, the sooner we can begin that work in earnest, rather than continuing to waste time defending positions that mathematics has already refuted. The practical challenges of studying an artificial interstellar probe are completely different from studying a natural comet. The observational strategies diverge. The analytical approaches require different frameworks. The questions you ask change fundamentally when you accept that you're looking at technology rather than geology. And that transition, that shift from treating 3I Atlas as unusual natural object to treating it as engineered artifact, requires institutional changes and resource reallocations and coordination across disciplines that normally don't interact closely, because understanding technology requires engineering expertise, materials science, propulsion specialists, computer scientists who might recognize patterns in signal data that astronomers wouldn't notice, physicists who work on plasma dynamics and electromagnetic field interactions, the full range of technical disciplines that contribute to spacecraft design and operation. The current observation programs are still largely designed around natural object assumptions, are focused on characterizing composition through spectroscopy, on measuring rotation periods and brightness variations, on tracking trajectories to determine gravitational influences. These are appropriate approaches for studying comets and asteroids, provide the data needed to understand natural bodies and their origins and evolution, but they're inadequate for characterizing technology. Miss critical information that would reveal how engineered systems operate and what capabilities they possess. If we accept that 3I Atlas is artificial, the observation priorities need to shift immediately. Time domain analysis becomes critical. We need to track how the object's behavior changes over time, whether emissions vary in patterns that might indicate operational modes. whether brightness fluctuations correlate with trajectory changes suggesting thrust events, whether the jet structures evolve in ways that indicate active control rather than passive response to solar heating. These temporal patterns are what reveal control systems in operation, are signatures of decisions being made and commands being executed rather than passive physics playing out deterministically.